To solve a nonlinear system of equations, your first move on this is to pick this equation or this one. It's your choice, but you should pick the one that doesn't have the square in it, if there is one. And there is. It is this one. Most of the time it's going to be this one. Sometimes you can use this one as well. The choice is yours. You have four different things you could solve for. X, Y, X, Y. Whichever one's going to make it easier. In this case, you just have a -1 against this y. This one you have a 3, so you would end up dividing by 3 all the way through with a bunch of fractions. So in this case, we may want to try this one that does have the square, which is not always the case, but in this one, let's try it. -x squared minus y equals -11. Keep the minus y where it's at, and move the minus x squared to the right. Divide everything by -1. So y is equivalent to this expression. That means you can plug it back into this equation for y. So we will do that and come up with 5x plus 3 times the quantity of -x squared plus 11. And set that equal to -9. Now simplify. 5x and then plus 3 distributed through the parentheses to get a -3x squared plus 33 equals a -9. Simplify where you can. Remember, you have to have ax squared plus bx plus c equals 0 to solve a quadratic equation. Here is the minus 3x squared. And then you have a 5x and a plus 33. The -9 can go over to the left and become plus 9, giving us the 0 on the right. And then -3x squared plus 5x, and 33 plus 9 is going to be plus 42. Completing the square, quadratic formula, or factoring, whatever you think would be easiest for you. But in this case, I'm going to use the quadratic formula to get -5 plus or minus the square root of 5 squared minus 4 times -3 times 42 over 2 times -3. So simplify under the square root sign. You have a double negative there and there. 5 squared is 25. It will be plus. And then you have to do 4 times 3 times 42 to come up with 504. On the bottom, it's a -6. Under the square root sign, 25 plus 504 is 529. Check to see if that's a perfect square by finding the square root of 529. And that will be 23. So now you have two problems to do. You have one that is -5 plus 23 over a -6, and one that is a -5 minus 23 over -6. -5 plus 23 is a positive 18. Divide by -6 to get a -3. Or it could be, on the right-hand side, a -28 divided by a -6. And when you reduce that, you'll come up with a positive 14 over 3. Those values have to be taken with you back to the top of the problem, so you can plug them into one of the equations for x, and therefore you can solve for y. So back to the top, you have these two equations to choose from. I'm going to choose the bottom one, 5x plus 3y equals 9. 5x plus 3y equals 9 came from, and that should be a -9 here. That came from this position here, the second equation. So we'll plug in the first value of x that we found, which was a -3. So 5 times a -3 plus 3y equals a negative 9. That's a negative 15 plus 3y equals negative 9. Move the minus 15 to the right, make it plus 15. That'll give you a positive 6. So 6 divided by 3 is going to turn out to be 2. That means when we plugged in a negative 3, we came back with a positive 2. That is one of your solutions. And you have to use the same equation, which again is 5x plus 3y equals negative 9, and plug in the 14 over 3 that we found as the second solution for x. So 5 times 14 over 3 plus 3y equals a negative 9. Multiply 5 by 14 over 3 to come up with 70 over 3. And now you have to move that to the right hand side. Change the sign to minus 70 over 3. A common denominator of 3 would give me a negative 27 over 3 and then minus 70 over 3. So that's a negative 97 over 3 that I have to divide by the 3 that's over there on the left-hand side. Negative 97 over 3 divided by 3 is the same thing as negative 97 over 3 times 1/3. So you get a negative 97 over 3. Or not over 3, but that should be a 9. Make it a mixed number. 9 goes into 97 10 times with 7 left over. So remember, we put in a 14 over 3. As a mixed number, that's going to be 4 2/3. We got back a negative 10 7/9. So that is your other solution. Here is all of the work that you should show for this problem. Solution 1, Solution 2. When you start a nonlinear systems of equations problem, you have 4 choices. You can get this x by itself, this y by itself, this x by itself, and this y by itself. You have 4 different choices. Most of the time you're not going to try to get this by itself because it will involve a square root, which could make things more difficult, though it's still possible. If you look up here, you would have to divide by 6 all the way through if you chose to get this by itself, or you would have to divide by 4 if you chose to get this y by itself. Even though dividing this by 4 would give you a 7, which is an integer, you would still have to deal with this. Down here on the bottom, you have a y that has a plus 1 in front of it, so that might be the best choice, so that you could do y equals 2x squared minus 74. That is equivalent to this y in that equation. So you can do 6x plus 4 times 2x squared minus 74, and then set it equal to 28. 6x is unchanged, but 4 times 2x squared is 8x squared, and 4 times a negative 74 would give you a value of 296, but that's minus 296. Set it equal to 28. Remember, you want this form, ax squared plus bx plus c equals 0. So we have the 8x squared, we have the 6x minus 296, but we can move this 28 to the left and make it minus. Now we have to simplify our constant terms there at the end. Negative 296 minus 28 is going to give me a value of minus 324. Quadratic formula, factoring, or completing the square. Anytime you have a value of something other than 1 on the x squared, completing the square is not a good option. Quadratic formula always is. Factoring, you could factor this, but it would be kind of messy and take a lot longer than just doing negative 6 plus or minus the square root of 6 squared minus 4 times 8 times negative 324. And then put that over 2 times 8. Simplify under the square root sign to get 36 plus, because of this double negative, 4 times 8 times 324, which would be 10,368. And on the bottom you would have a 16. Now under the square root sign, you'll have 36 plus 10,368, which is 10,404. And that would be over 16. Check to see if 10,404 is a perfect square. It is, and the square root is 102. So we would have negative 6 plus or minus 102 over 16, which would give us two problems, a negative 6 plus 102 over 16, and a negative 6 minus 102 over 16. This is going to be 96 over 16, which works out really neat because the answer is 6. Or it could be a negative 108 over 16. If you reduce 108 over 16, forget the negative sign for now, that would be 54 over 8, 27 over 4 would be where it ends up. So you need to go back to the top and use 6 or a negative 27 over 4 to figure out your solutions. The equation we should use is the top one up here, 6x plus 4y equals 28. So 6x plus 4y equals 28, and if I dump in a 6 in for x, I'm going to come up with a 36 plus 4y equals 28. And then 4y would equal 28 minus 36. That would give us a negative 8 on the right. Divide the negative 8 by 4 to get an answer of 2. So we plugged in a 6 and came back with a 2. So there's one of your solutions. Now you have to go back through and do the same thing for 6x plus 4y equals 28 by plugging in the negative 27 over 4 that we found. So 6 times a negative 27 over 4 plus 4y equals 28. 6 times 27 is going to be 162, but that's a negative 162 over 4. And then we're going to have to move that to the right side and come up with 28 plus 162 over 4. And then add those two fractions together. 28 over 1, if you make it a denominator over 4, 28 times 4 is going to be 112. And you're going to add to that 162 and put the result over 4. 112 and 162 is going to be 274. And that's going to be over 4. But you have to divide it by the 4 that's with the y. So that's the same thing as 274 over 4 times 1 over 4, which will give me a 274 over 16. That can be reduced. You can chop them down by 2's to come up with 137 over 8 and then make it a mixed number. Figure out how many times 8 will go into 137. It goes in 17 times, and 17 times 8 is 136, so you have 1 left over. Now remember, you put in up here a negative 27 over 4. So a negative 27 over 4 is the same thing as having a negative 6 3/4. So that's what we put in, was a negative 6 3/4. What we got back was 17 1/8. So your two solutions for this problem can be found here and here. Here is one correction I need to make, and that should be a negative 2. Clearly it's negative 8 divided by 4, and I simply put a 2 down. If I said negative 2, the mark didn't show up, so whatever the case, this should be 6 negative 2. To solve this system of nonlinear equations, you're going to have to determine which one you're going to solve for in terms of variables. Notice that this and this both have 1's attached to them, which makes it easy. Down here you have a negative 1 and a negative 1. That could still be easy, but I think we should stay up here and try to get y by itself. So that would be y equals a negative x minus 6. And we are going to put in this expression in for this y. So that would be a negative x squared minus the quantity of negative x minus 6, and then equals a negative 24. Simplify that to get negative x squared plus x plus 6 equals a negative 24. So you have negative x squared plus x plus 6, but that minus 24 must join the left side and change operations. Simplify your constants at the end to get a plus 30. Like that. You do have the option of doing the following. You can do the quadratic formula now, or you can factor, because notice you have a negative 1 here. You can change the sign of everything through here by multiplying by a negative 1 to get x squared minus x minus 30. So that would make it easier for you to factor, since you would not have a negative sign there. It is legal to do that. And if you factor this, it's really simple. You'll have x plus 5 and then x minus 6, which will quickly give you the solutions of x equals negative 5 or x equals 6. So we need to take negative 5 and 6 to the top and plug it back into that top equation. X plus y equals negative 6. X plus y equals negative 6, and plug in the negative 5 first. When we do that, we'll come back with negative 6 plus 5, which is a negative 1. So we put in a negative 5 and came back with a negative 1. Now let's start over again with x plus y equals negative 6, and this time we are going to put in a 6. So 6 plus y equals a negative 6. That would be negative 6 minus 6, which is a negative 12. We put in a 6 and came back with a negative 12. Your solutions should be this and this.